For this tutorial, I have the Stack Overflow Developer Survey 2022 dataset. It's called survey.csv. This is around 103.79 MB, which is a good amount of data. So let's just get started with it. Let's start by installing Polars. Because I already have it installed, it says requirement already satisfied, but usually it runs for about 15 to 20 seconds and installs the package. So now let's import Polars. Let's also import Pandas just to see a basic comparison between both of them. So let's try to load the dataset that we have in both Polars and Pandas and see how much time it takes. Starting with Pandas, I will time it. That took about 3.17 seconds. Let me try the same with Polars. It took about 483 milliseconds, which is way lesser than 3.17 seconds. Now let's get started by exploring few different ways in which we can manipulate data using Polars. So let's load the dataset. Similar to Pandas, Polars also has a head function which will print out the first 5 rows. And as you can see, these are the column names, and then these are the type. I64 is integer 64-bit, string, string, string. And as you can observe, we have lots of NA values as well. And you can see that this has to be a float or an integer, but it is of type string because of the NA values. We will correct these. And these are the various columns. Now let's get started by removing the NA values. The Polars package cannot recognize these as null values, mainly because these are of type string. We have to convert them to a different format. We can do this by the df.apply method. So this method runs on every row and gives us a tuple value which contains each cell of that row, and we can modify it. So we need to write a lambda function in order to make this happen. Lambda t. So t here is one complete row with all the values in that row. So what we have to do is, in a particular row, if we come across any NA value, we have to make it as none or a null value. So let's do that. We have to return a none value if x is equal to NA, else return x as is. Now where do we get this x from? We get it from for x in list of t. So we convert this t tuple into a list so that we can loop through it, and if that t is a NA value, then we return none. So now we cannot return a list back because Polars gave us a tuple value and it wants a tuple value back. So let's convert this into a tuple. Okay, that looks good. Let's run it now. So here is the result. As you can see, this df.apply has returned a data frame as its return value, and you can also see that the columns here are, we have lost the column names. The column names previously were these, and now it's just column 0, 1, 2, 3 and so on. So we need to retain the column names, and also we need to store this in a variable. So let's do that. So columns, df.columns. So what this does is it gives us a list of columns. This is similar to how pandas also gives us a list of columns. And now what we can do is we can assign this to df itself, and we can say df.columns equal to columns. So this would write the values of column names to the new data frame that we get. Now let's run this. Okay, that ran successfully. Let us check the value of the data frame now. So as you can see, it has replaced our NA values with null values here. And let's go a bit forward and let's do a bunch of things. So first, let me print out all the columns that there are so that we can select a subset of columns and work with them. We have all these columns. And let me choose a few columns here. This is a list of random columns that I've chosen. One is employment, remote work, coding activities, their education level, years of coding professionally, age, work experience, and converted compensation yearly. So this is the yearly compensation of the developer converted to dollars. So now let's get a subset of this data frame that we have. To do that, all we have to do is call the select method. The return type of a select method is a data frame itself, so we have to store it in a variable. Now let's check if we have all the columns that we asked for. As you can see, it has given us the columns that we asked for. We still have the null values though, because it's just a subset of the data frame. Let's clean up the null values now. So if we call subset dot drop nulls, this would drop all the null values, but then this is also returning a data frame back. So I will assign this to the subset variable itself. Once that is done, let's see our data again. And as you can see, this is clean without any null values. We can sort of go ahead now and modify a few things here. So the first thing I want to do is convert these string values into float so that we have good amount of numbers to work with. To do that, all we have to do is subset dot with columns pl.call means pl.columns. I need a column which is this, years coding professionally, dot cast. I want to typecast it into a different format, pl.float 64. And do I want a strit conversion? No, I don't. So strit equals false. So let's see what this gives us. And this again returns a data frame. And as you can see, years coding professionally, the column has been changed to a float 64 and all the values are in float. So we have to store this as a variable again. And let's do this for the other two columns as well. Work experience, converted compensation yearly. So we can convert all of these into functions, which make it much easier for us to access when required. For now, I just go ahead with this as is. So now if we look at the data set, it looks like this. These are all strings, we're fine with that. And then we have the float values that we need. Now here's a question I came up with. Using this data, can we make out if having a master's degree is better than having a bachelor's degree? So let's see what all education levels are present. To do that, all we can do is subset.select ed level or the education level, which will select this whole column. In this column, what we need is all the unique values. So I can do dot unique, and this gives me the unique values, but as you can see, they are cut off by the collab displaying method. So we can just call rows on top of it, and this would give us the value as a list of tuple. So what's present is master's degree, bachelor's degree, something else, secondary, high school, and all these. All I'm interested in is master's degree and bachelor's degree. So now let's filter this subset based on the master's and bachelor's degree. So to filter the dataset, we can call the filter method. And in this filter method, we have to provide a function by which it filters things. So to do that, I'll call pl.call again to get the column that we want, that is education level dot. So there are a few different ways in which we can filter based on the values that we want to filter. So this is a string. It can be a float or boolean or whatnot. And Polars has methods which accompany the type of data that we want to filter. For example, here we want to filter out strings by using string contains. So I will type str dot contains bachelor. So I want to filter out all the rows that has education level column containing bachelor. So all of these methods return a data frame, so we have to store them in a variable. And if I print out the first 5 rows, we have all the rows here which have the education level of bachelor's degree. Let's do the same for masters as well. So here we have a new data frame which has education level of masters, and this is for education level of bachelors. Now we can go ahead and make our comparisons. So what I'm thinking to do is to group these data frames by the years of coding professionally, and then getting the mean compensation yearly for that particular year of experience. So let's get started with that. To do that, what we have to do is get this data frame that we already have, dot group by. What do we group by is years of coding professionally. So once we do a group, we get a sub data frame containing all of the values that we need for that particular group. And in these values, what I want to do is get the mean of this converted compensation yearly. So how do we do that is by using the aggregate method. In the aggregate method, what we can do is we have to pass another inner function, pl.mean. This gives us the mean or the average of this particular column. And then what we can do is we can add a suffix to make sure that the column that we are naming has some meaning towards it. So if I just execute this as is, you can see over here that it has given us the column, this same column, but it has appended underscore mean to it, which is the suffix that we gave. And this is for all the different years of coding professionally. So now let's store it in a variable again, because this is a data frame, and do a similar thing for masters. So now that I have both of these data frames ready, let us see what they have and how we can use it. For the bachelor aggregate, we have years of coding professionally and the mean itself. And similarly for the masters, we have years coding professionally and the mean itself. So if you can observe here, the years of coding professionally is a column that is same in both of these, and then we have the mean. So what we can do here is we can join these two on the years coding professionally column, so that we can get just one data frame in which we can compare different things. So to do that, what we'll do is we'll call the bachelor aggregate dot join master aggregate, and join on what is the years coding professionally, because both the data frames have this column, and I would like to add a suffix. So this suffix is added to this particular data frame. So as this is the masters data frame, I would like to add a suffix of masters, and this would give us something like this. We have the years coding professionally, and we have the converted compensation mean for both of these. And let's store this in a variable. Let's see how the values are. And we can also see how big our data frame is by using the polars method, such as df.height. Height will give us the number of rows that are there, and similarly we can do df.width. Width gives us the number of columns that are present. We have 3 columns, and then we can also do dot shape, which would give us this. And similar to pandas, we can also try describe method, and this will give us the various count, null values, mean, standard deviation, min, max, median, and all those values. So now let's get back to our comparison that we were doing. With the years of professional coding experience, I want to compare the mean of bachelor's degree versus the mean of the master's degree. So to do that, what I want to do is I want to get the difference between these two. So I want to add a new column which would have the difference between the master's and the bachelor's for the years of coding professionally. So let's do that. To do that, all we have to do is combined data frame that we already have dot select. So while selecting, we can pass in the columns that we want, and we can also create a new column. To do that, I'll create a new column where I have pl.column, where I have the mean that we want, minus pl.column of the masters. So let me actually do it the other way around. Masters minus the bachelors. And if I execute this, I just get one column, which is converted compensation mean masters, which is masters minus the bachelors. That's the reason we have a few negative values in here. So to add it into the data frame that we already have, all we have to do is pass in the columns that already exist. To do that, what we have to do is combined data frame dot columns comma this, the new column that we're passing. But then what would happen here is this combined data frame dot columns is an array itself. So this would be an array inside of an array. So to convert this array into just values inside of the outer array, we need to spread it out using the spread operator. And once we do this, this will still throw an error, but let's just see what happens. So what it's saying is the masters column is already present. So what it's doing is the new value that we're trying to create, it's assuming this to have the same name as masters. So what we have to do here is give it an alias that is dot alias of diff. So this will create a new column called diff, which will contain the difference between these two columns. So now using this particular data frame that we have, we can make a few conclusions. So because this is a data frame that has been returned, let me also store it in a data frame. So I'll call it as diff, and now diff.head has 4 columns in it. One is the years of coding professionally, the mean of bachelor's degree, the mean of master's degree, and the difference itself. So on this data frame, we can perform filter operations, we can sort it so that we know few different values and we can draw in conclusions regarding those values. To do that, what I'll do is diff.filter. So the filter method, again, we can pass in we can pass in functions which would filter our data frame. So I want to filter it by the difference call, which is lesser than 0, meaning if the difference call is lesser than 0, then the bachelor's degree mean is higher than the master's degree mean for the same years of coding experience. And then I can sort it by the column, which is diff again. So we have the highest difference in years of coding of 38, and then 16, 26, and so on. We can also sort it the other way around by the years of coding professionally. And here you can see it goes from 1 all the way till 48. And what we can do is we can get the shape of this. So there are like 32 rows where the bachelor's degree has more average per the same years of coding experience than the master's. So now let's do it the other way around. Let's check where the master's degree has more income than the bachelor's degree. It's in 15 rows. So we can print these out together. For example, I can make this as height. This is for better income with a bachelor degree. This is for a better income with a master's degree. Run these two. And then print them out. And here we go. These are the values. So this is how you use polars. It is very similar to pandas but much faster.